Solving tangent x and cotangent x with the simple calculators. I derived these formulas for solving the approximate values of tangent x and cotangent x using simple calculators with the memory plus key and preferably with a plus over minus, that's a change sign key, for ease of operation. These formulas are derived from Taylor series of tangent and cotangent, but they were truncated at the second term, but added a correction factor to the denominator to compensate for the truncation. The derivation of these formulas will be explained in another videos that will be released soon. These formulas are tangent x approximately equal to x plus x cubed over 3 minus 1.203622x squared. This one is the correction factor. Cotangent x approximately equal to 1 over x minus x over 3 minus 0.20359x squared. The cotangent x formula is not very convenient to use as is with the simple calculator, so I reconfigure it so that it can be solved now non-stop with the simple calculator. And this formula is now transformed as cotangent x approximately equal to 1 minus x squared over 3 minus 0.20359x squared, all divided by x. And the procedure for solving these tangent and cotangent is: number 1, the value of x is in radians. The first step is to convert the given degrees into radian by multiplying by 3.141592654, then divide by 180. Store this value as x into the calculator by pressing the memory plus key. This value can be retrieved by pressing MR key. Step 4. Press MR to retrieve the value of x. Press multiply key, then equal key to get x squared. Multiply the correction coefficient, which is 1.203622 for tangent formula and 0.20359 for the cotangent formula. Number 7, subtract the constant 3 from the value obtained in step 6. From this step 6, you subtract the value of 3 from both tangent and cotangent. Then the next step is press, divide, and then memory recall 3 times for tangent formula and 2 times for cotangent formula. The reason is to get the x cubed and the x squared. But by doing so, you're only getting the reciprocal of it. So what you do is you press divide and then press equal to get the reciprocal, to reinvert the formula. So it will now, after inverting, it will be now equivalent to x cubed divided by 3 minus 1.203622x squared for the tangent, or x squared divided by 3 minus 0.20359x squared for the cotangent. And subtract x from the above value by pressing MR. And that is for the tangent. And for cotangent, you subtract 1 from the respective value for the cotangent. For tangent, the step 10 is already the answer. And for cotangent, divide the value in step 10 by x by pressing divide then MR, and you will get the answer. The procedures that I've said sounds to be a bit complicated, but if you explain it using the formula, then it will be more easily understood. The first thing is this one. Attack the problem from here. You get the value of x, you square it, and then you multiply it by this coefficient 1.203622, and then you change the sign with the change sign key, and then you add 3. And after that, you divide by x 3 times. This value divide by this one 3 times. So you're getting the reciprocal of x cubed. After you get that, then you press divide equal to reinvert back the formula into this form. And then finally, you add the x from the MR key, and you'll get the tangent. And for the cotangent, it's also the same. You start from the x square. You retrieve the value of x from MR. You square that one. That's times equal. And then you multiply it by 0.20359. After that, you change the sign with the positive negative key. And then you add 3. And you divide it by x twice. Divide the MR twice to get x squared. And then you divide equal in order to reinvert it back. And then you change the key of this into negative, and then you plus 1. And then finally you divide it by the MR, that's the x stored in the memory. And you'll get the cotangent value. I will demonstrate how to get the tangent of 30 degrees. You input 30, you multiply it by 3.141592645. And then you divide it by 180. And you store it in the memory plus. And use this value that is in radian. And using this value and looking at the formula, first you get the x squared value. You multiply and equal, that's x squared. Multiply this by the coefficient, correction coefficient, 1.203622 equal. And then you change the sign of this value by pressing this positive over negative key. And then you plus 3. After that, you divide the memory MR key to divide the x 3 times. 1, 2, 3. That's for x cubed. But then you flip the formula back by pressing divide equal. And you get that right side up formula. And then you add back the x, which is in the MR. So this 0.5736 is the equivalent of tangent 30 degrees. For cotangent 30, we use the same radian value and we retrieve it by pressing MR, and that is the radian value of tangent of for 30 degrees. And first we get the square of that x squared by pressing multiply equal. That's x squared. Multiply by the coefficient 0.20359 equals, and then we change the sign and we plus 3. And then we divide it by the memory twice, once, 2. And then we press divide equal to flip the value back. And then change the sign and we plus 1 equal to this. And this value now divides the x stored in the MR. And this is what you get. That is now cotangent 30, 1.730. From the demos, tangent 30, we got this value, and the true value is this one. So 4 decimals, they're the same, 57736, so up to the 4 is the same. Same with cotangent, 1.7320, this 1.7320, that's 5 digits. These formula are best for angles below 50 degrees. So I suggest a cut off at 45 So for angles greater than 45, get the tangent or cotangent of the complementary angle. Then get the reciprocal by flipping it. Example, tangent of 75 is actually equal to tangent of 90 minus 75. That is tangent of 15 degrees. So you solve for tangent of 15 degrees. After you get the value, you flip it by getting the reciprocal. That's why it's raised to the negative 1. Same thing with cotangent 80. That's equal to cotangent of 90 minus 80 equal to cotangent of 10 degrees. After you get the cotangent of 10 degrees, then you flip it by raising to the negative 1. And that's how you get cotangent of 80. These formula give impressive accuracies for very small angles or the complementary angle thereof. Note, tangent and cotangent are reciprocal in relationship. So actually one formula is needed to get the tangent or cotangent of any angles between 0 and 90. If you can make use of the reciprocal and complementary angle relationships. For example, tangent 1 degree is equal to cotangent of 89 degrees. And tangent of 89 degrees equal to the reciprocal of tangent of 1 degree. Cotangent of 1 degree is equal to cotangent of 1 degree equal to tangent of 89. And cotangent of 89 is equal to cotangent of 1 degree raised to the negative 1, the reciprocal way. You can try solving for this angle and have fun yourself. We now try to solve for tangent of 1 degree. So 1 multiplied by 3.141592654 and divided by 180 stored in the memory, and that is in radian. That's equivalent to tangent to 1 degree. And from the formula, we try to get the cotangent of 1 degree. So what you do is you get this value, then you multiply to get the square, and then you multiply by the coefficient 0.20359, and then you change sign, you plus 3, and then you divide by the memory recall twice, 1, 2, and flip it back by reciprocal, and then change sign, you plus 1, and finally you divide it by the memory, the x, and there you get the cotangent of 1 degree is 57.28. We can try. If you get tangent of 1 equals, and then you get the reciprocal of it, see from the scientific calculator, 57.289966163, and this is the answer for that from the simple calculator. Almost the same.